Hi, so today I'm going to be going over power rails, what power rails are, how to find them on a schematic, and what the importance is of them when you're troubleshooting something that doesn't work, something that doesn't turn on, or something that isn't doing what it's supposed to. So every piece of electronic component obviously runs off of electricity, and it's not just the electricity from your wall outlet. It's not like you plug something into the wall and the 120 volts of AC from your wall instantly gets transported and is being sent everywhere. We turn that into different levels of power for different circuits. The CPU uses 1 volt of DC. A charging circuit uses 12 volts of DC. The backlight circuit uses 27 or 35 volts of DC. My amplifier uses 80 volts of DC. Like a motor may use 45 volts of AC. An iron may use the 120 volts of AC for the iron, and maybe 5 volts of DC for some digital logic circuit for for the knob or for any of the readout on the screen. Point is, every circuit has different power rails for different parts of it, and you need to be able to troubleshoot this. You need to know what a power rail even is in order to get started with any type of basic electronics troubleshooting. So let's just show you what that is on the screen over here. All right, so this is a MacBook schematic. Okay, so on this schematic, we're going to scroll. Now, let's just scroll to the point where it lists power rails. That's nothing. That's nothing. Okay, here we go. So on the bottom right, it says power aliases, same shit as power rails, and we have a description over here of all the different rails. So SO rails. So I didn't explain this in another video, but S5 means computer is off, S3 computer is sleeping, SO computer is on and you're using it. So S are different states. So when the computer is on, these are rails that you're going to see. So in this computer, you have a vCore rail. So this is a rail for the CPU, and it says the voltage is 1.25 volts. Over here, it says this is a 1.05 volt rail, and it's called PP1V05_SO. These are all the power rails that are pretty much the same as this. So this rail goes to all of these different things, and they name this rail something different for all the different parts that it goes to. So it goes to the CPU, it goes to the MCP, it goes to SATA DVD, it goes to FireWire, power, control, it goes to all these different things. So every time you see this, you should expect that 1.5 volts be there. So if you don't have PP1V05_SO, that means you're not going to have any of these things. So and part of being good at troubleshooting, part of being good at being able to go through this and make things work is knowing what power rails to check first, what power rails to check second, what to check third, what turns into what. So one of the main rails in this system, if you really become acquainted with the schematic and get used to how everything works, is PP-bus G3 hot. So this is a 12.6 volt voltage that gets used for just about everything. So just so that you can become a little bit familiar with how this works, let's see, I want to go to PP-vCore_SO_CPU. So this is a power rail for CPU voltage. So I'm going to go to where this is created. Okay, so this gets created right over here, right? Now this is a buck converter like I told you. So this takes a higher voltage and turns it into a lower voltage. So you need to have that higher voltage, obviously, before you can create the CPU vCore. If you don't have this, which is getting turned to this through little pulses, then how the hell are you going to get to this? You need this first. So PPVin_S5_CPU_IMVP. What is that? Let's see. Here we go. So over here it says this is a 12.6 volt rail. And it's right under PP-bus G3 hot. So this is pretty much the same as this. So over here you have a current sensing resistor, and so over here it says PP-bus_S5_CPU reg S_I6_R. That is a sub rail of PP-bus G3 hot. So this is going to be 12.6 volts. That's the same as this. And over here, this over here, this PPVin S5 CPU IMVP is a subrail of PPBus S5 CPU Regs iSense, which is a subrail of PPBus S5 CPU Regs iSense R, which is a subrail of PPBus G3 Hot. So this is pretty much the same as this, which is the same as this. So if you don't have PPBus G3 Hot, you won't have CPU vCore. Obviously, now if you're used to how these circuits work, that you're going to say, well, duh, I don't need that explained to me. But again, this is really something for this video series is meant for people who have no idea how electricity works. And I'm trying to explain it step by step, so don't be a jackass and condescending. Thank you. So you can do this for just about every part of the circuit. So for example, let's say that the one-wire circuit is not working. So this is a good example because this is very common. I talked about what the one-wire circuit is in another video, and if I remember, I'll put an annotation here that you could click to learn about the one-wire circuit. Over here you have PP3V42 underscore G3 hot underscore one-wire. Now that is a subrail of PP3V42 underscore G3 hot. If you don't have PP3V42 underscore G3 hot, you cannot have a one-wire circuit, which means you cannot have a green light on your charger. So having some knowledge of what the power rails are, having a knowledge that you should have 3.42 volts at that point, is going to help you troubleshoot the circuit. So one of the first things that you should do with any type of troubleshooting is simply go through and see if the power rails related to the parts of the circuit that don't work are there. So I went into this board view program, which you're probably going to ask me where I got it, even though the website's on the screen in the back of every single PDF for the last 2 years of this video series. I hit N, I put PP3V42 underscore G3 hot, hit enter, and now what it does is it shows me everywhere in the board that that is supposed to show up. Now, if I measure here, and I'm trying to turn the computer on and I measure here and I get 0 volts, well then PP3V42 underscore G3 hot is missing. I should check if it's at other places, and if it's nowhere, then I know I need to start troubleshooting that circuit. If I do see PP3V42 underscore G3 hot there, which over here, again, people are going to go, what the hell is PP3V42? It says over here, voltage, 3.42. And even if you don't have it saying voltage over here, 3.42, 3V42, if you measure it on a good board and you see that there's 3.42 there, and you see that the schematic calls it PP3V42, eventually at some point it should click that that's a 3.42 volt power rail. So this is pretty much power rails. They're just different rails of power. I know you're not supposed to use the word to describe the word that you're trying to describe, but it really is that simple. It's just a list of all the voltages that are needed for the computer to do different things, and if some of them are missing when they're supposed to be there, then you know that that's the part of the circuit that you start troubleshooting. So it's not like you look at this board and you're like, oh my god, where do I start? I have to test every single component? Because that's the first thing most people think when they get in the motherboard repair, right? They think I'm a genius because they think that I look at this and I psychically decide by putting my hand over the board, closing my eyes and putting it around it like this is the component that's bad. No, it's logic. You look here and you see that there are a list of power rails. Now, what I do is I use my little program because, again, I'm not fucking psychic. I'm not. A lot of people think that people who do board repair are psychic and they just know what all this is. No, this is what this little program is here to do. This program is here to tell me what these things on the board actually are. I have no fucking idea what like that this is the inductor for PP3V42. I'm not going to know that off the top of my head if I've never worked on this board. So that's what this thing does over here. It pretty much tells me where these things are so that I can then measure them and then I can start troubleshooting. So if I see that that's not working the way it's supposed to be, I know to focus on that section of the circuit. So PP3V42 comes out of L6995. Let's say that's not there. I can go here, go L6995, and what do you know? Look, now I can look at this section of the circuit. Now maybe I see that that thing's burned or that thing's burned, and I start to get an idea of what's going on. Or maybe one of these resistors is burned or doesn't measure the way it's supposed to. I assure you that whoever designed this computer did not design it with the idea that you could just be missing random power rails and the thing could still work. You need most of the power rails that are there. Obviously, some like the T29 for DisplayPort and Thunderbolt. If the board has a hole in it and it's been pissed on, you can get away with just trying to sell somebody on. They're not going to have no DisplayPort or Thunderbolt if it's been pissed on and has a hole in it. But for just about all these other power rails, you need PPBus G3 hot to be there. You need PP3V42 to be there. You need PPVCore underscore SO underscore CPU to be there if you expect the computer to actually do anything. And again, the schematic here, even though it's confusing, it's listing the rails. So again, I'm going back to this page over here where it lists every single rail. It even tells you what is supposed to be there for different parts of the system. Okay, so let's try to use a real world example if some power supply is missing and how to figure out what's going on. So let's say PP5VSO is missing. So you plug the thing in and it's supposed to have PP5VSO, but it doesn't. Let's see how PP5VSO is created by just searching through the schematic. So PP5VSO is used for the hard drive. It's used for CPU stuff. It's used for more CPU stuff, more MCP stuff. It's used for the fan. It's pretty important. If you don't have PP5VSO, your computer's not going to work. So let me show you how you can just start getting an idea of how to troubleshoot this and what the order of everything is. So I hit Control F and I typed in PP5VSO in my corner, and I'm just hitting Enter to go through all the things it's used on. So it is used on this the hard drive. It's used to power the fan over here. It is used to power the buck converter controller chip for CPU vCore. So if you don't have that, the CPU is not going to turn on. It's used to power the buck controller chip for MCP vCore. So that will not turn on without this power rail. And eventually we are going to get, here we go. So how is it created? So PP5VSO comes out of here. And it comes out of here when there is nothing on this gate. So the way this works is when P5VSO enable is on this transistor, it's going to send this over here. It's going to send that signal to ground, which is going to allow this P-channel MOSFET to open and send PP5VS3 over to the drain, over to the system. So PP5VSO comes from PP5VS3. Let's see what PP5VS3 comes from. Now PP5VS3, I'm just going to hit Enter on that power rail and go through. So here we go. So PP5VS3, this is the rail that PP5VSO comes from. Now I want to figure out how this is created. So this powers PP5VSO, and it also powers trackpad, the wireless card, MCP something, RT, USB, infrared, optical drive, Bluetooth, and some other stuff that I don't know what it is because I forget. Here we go. So that's the wireless card. We're going to keep scrolling through here and scrolling and scrolling and scrolling. Come on, show me the PP5VS3 power supply. Okay, it's audio codec. That's boring, 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 boring. Here we go, 5-volt S3 power supply. So that's PP5VS3 that's coming out of a buck converter. So we have two transistors, an inductor and smoothing capacitors on output, and these two transistors are controlled by a controller chip. What does this look like to you? This is a buck converter. And again, you need to be at a point after you're done watching this Introductory Electronics video series that when you see this, it clicks in your head. I don't have to ask you what it is. You see it and you go, aha, this is something of interest to me. Now, at the top of the buck converter where the source power supply is, you have PPVin underscore S3 underscore 5ES3. That's this over here. So this is what's responsible for creating PP5ES3. So let's see what this comes from. That is over here. That is a subrail of PP-BUSH-G3 hot. So you need PP-BUSH-G3 hot to be 12.6 volts in order to get PP5ES3. You need PP5ES3 to be 5 volts to get PP5ESO. So if you don't have PP5ES3, before you start troubleshooting that circuit, before you start doing a fucking thing to it, the first thing that you should be doing is saying, do you have PP-BUSH-G3 hot? If PP-BUSH-G3 hot is not 12.6 volts, you will never get 5 volts out of PP5ES3. It's not going to happen because PP5ES3 comes from PP-BUSH-G3 hot. This is why it's important to get to know your power rails and to know how to troubleshoot power rails, how to measure them, and also how to say, okay, this doesn't exist. Let's see if the power rail that creates this power rail works before you start going nuts down a rabbit hole. Now, the whole idea here is I don't want you to be dependent on me to figure this out. I want you to be able to Control F and then be able to figure out on your own what power rails are creating what other power rails by simply searching through, by saying, okay, this is the input for the creation of PP5ES3. Let's search and see where that is on the power rail list. Okay, that comes from PP-BUSH-G3 hot. So that means that if 12.6 volts doesn't exist, I can stop troubleshooting the 5-volt circuit because the 5-volt circuit, even if it worked fine, will never create anything because my 12-volt circuit doesn't work. This is the importance of being able to troubleshoot power rails, of knowing and understanding how they work and where they are in a schematic so that you know what to look for, so that you know what to troubleshoot, and so that you're chasing the right rabbit. I'm always talking about the rabbit hole to hell. The rabbit hole to hell is as Eli, the computer guy, so eloquently described it about 5 years ago. It's a little rabbit that you just think it's right in front of you, and you'll be able to, all you got to do is just do one more jump and you'll be able to catch the rabbit. But rabbits are really fast, so it's going to just jump one more time. It's not going to run away from you to where you can't catch it. It'll still be right in front of you, but it's so fast that you can't catch it. You see, you just go, okay, let me just follow one more, just one more, and you wind up following that rabbit all the way from your nice office space with your nice desk and soldering equipment. You wind up following him all the way down to hell, and that's bad. And again, you need to have the right tools and the right mindset so you can catch that little fuck before he takes you down to hell. I'm good enough at this point where for most problems that I got that rabbit before he even leaves the corner of the block. But if you don't know what you're doing, if you are chasing PP5ESO and PP5ES3, for hours upon hours without even noticing that your 12-volt input isn't there because you don't know how to find the list of power rails or how to just hit Control F and copy and paste to find where the stuff is and then find it in the schematic, you're screwed. And that rabbit is going to take you all the way to hell. And once he takes you all the way to hell, it's going to be really hard to get back and get focused on everything else.